We now discuss the solution of a problem from the section Differential Equations. This is the second question based on the concept of the solution curve. This question has appeared in the joint entrance examination main held on 26th June 2022 in the first shift. The given question is, let S is equal to the open interval 0, 2 pi minus the set consisting of pi by 2, 3 pi by 4, 3 pi by 2, 7 pi by 4. Let y is equal to y of x, where x belongs to S, be the solution curve of the differential equation dy by dx is equal to 1 by 1 plus sine 2x, y at pi by 4 is equal to 1 by 2. If the sum of the abscissas of all the points of intersection of the curve y is equal to y of x with the curve y is equal to root 2 sine x is k pi by 12, then k is equal to. We are given a set S that is equal to the open interval 0, 2 pi except pi by 2, 3 pi by 4, 3 pi by 2, 7 pi by 4. And we are given a differential equation dy by dx is equal to 1 by 1 plus sine 2x with a initial condition y at pi by 4 is equal to 1 by 2 and y is equal to y of x, where x belongs to S, is the solution curve of this differential equation. And this solution curve y is equal to yx and its intersection, the points of intersection of this solution y is equal to yx with a given curve y is equal to root sine x, and if you take the sum of the abscissa of all such points of intersection, and if it is given to be k pi by 12, then what is the value of k? That is the sum of the abscissa of all points of intersection of the solution curve with the given curve y is equal to root 2 sine x. If it is given to be k pi by 12, find the value of k. That is our given question. We now discuss the solution of the problem in detail. We are given a differential equation dy by dx is equal to 1 by 1 plus sine 2x. And as it is, the variables are separated. The solution we will obtain simply by integrating. Integral of dy is equal to integral of 1 by 1 plus sine 2x with respect to x. For 1 we have written sine square x plus cos square x. Then 1 by the denominator becomes sine square x plus cos square x plus sine 2x is 2 sine x cos x, that is sine x plus cos x whole square. So integral dy is equal to integral of 1 by sine x plus cos x whole square with respect to x. In the denominator, take a cos x whole square common. That's equal to, that implies y is equal to integral 1 by cos square x in brackets. That will be sine x by cos x, that is tan x, plus cos x by cos x, that is 1. That is 1 plus tan x whole square with respect to x, plus c, where c is an arbitrary constant to be evaluated. This integral, this is equal to integral 1 by cos square x, we have written secant square x by 1 plus tan x whole square with respect to x plus c. Now we integrate by taking 1 plus tan x as u, then du is equal to secant square x dx. Then the integral becomes secant square x dx is du, integral secant square x dx is du by 1 plus tan x whole square is u square. The integral of 1 by u square with respect to u is u power minus 2 plus 1 by minus 2 plus 1, that is precisely minus 1 by u, that's equal to minus 1 by 1 plus tan x. That is the integration part, integration here. So we go back here. That will be equal to minus 1 by 1 plus tan x plus c. Agreed. Now this is a solution containing an arbitrary constant. Therefore, we will get a general solution. Y of x is equal to minus 1 by 1 plus tan x plus c. And to evaluate this c, we are given an initial condition. Y at pi by 4 is equal to 1 by 2. So in the general solution, substitute x is equal to pi by 4. So y at pi by 4, it is given to be 1 by 2 is equal to, substituting here, minus 1 by 1 plus tan pi by 4 plus c. Tan pi by 4 is 1. It is minus 1 by 1 plus 1 plus c. That is minus 1 by 2 plus c. So thus we got minus 1 by 2 plus c is equal to 1 by 2. From this we get c is equal to 1. And replacing c by 1, we get a particular solution. What's the particular solution? Y of x is equal to minus 1 by 1 plus tan x plus c is 1. We continue in the next slide. That's what we have done so far. We simplify this y of x as y of x is equal to, take the LCM, then in the numerator you will get minus 1 plus tan x, minus 1 plus 1 cancels and you get tan x by 1 plus tan x. That is our particular solution, where x belongs to S, where S is, we have already taken that it is equal to the open interval 0, 2 pi except pi by 2, 3 pi by 4, 3 pi by 2, 7 pi by 4. In the beginning, the student will get, will get a doubt why these 4 elements are taken out from the open interval. And the reason is, in this solution, 1 plus tan x becomes 0 for the x values that it takes these 4 values. At these 4 values of x, 1 plus tan x becomes 0 and thereby the solution doesn't exist at these points. Therefore, these points are eliminated and thus our solution exists and it is meaningful. Agreed. Agreed. Now, what is to be done? What is to be done? So, you take your curve y is equal to y of x and take the given curve y is equal to root 2 sin x and the points of intersection you find out. And in that points of intersection, take the x coordinates, that is abscissas, and you sum it up. Then you will get sum of abscissa of the points of intersection, and that is given to be k pi by 12. Equate it, then solve for k, you will get your answer. So now you take your y is equal to y of x, and the given curve y is equal to root 2 sin x. The points of intersection is obtained by this. That is tan x by 1 plus tan x is equal to root 2 sin x. And solving, you will get the values for x, that is the values of x coordinates, that is the values of the abscissa of the points of intersection. This will imply tan x, we have written sin x by cos x and simplified, you get sin x by sin x plus cos x is equal to root 2 sin x. Now, send this root 2 sin x to the left hand side, then you will and take the sin x common, sin x into 1 by sin x plus cos x minus root 2 is equal to 0. This will imply sin x is equal to 0 and 1 by sin x plus cos x is equal to root 2. From that you will get sin x plus cos x is 1 by root 2. Agreed. Now multiply throughout by 1 by root 2, the second equation. Then you will get sin x into 1 by root 2 plus cos x into 1 by root 2 is equal to 1 by root 2 into 1 by root 2, that is 1 by 2. And this is sine of x plus pi by 4. So sin x is equal to 0, sine of x plus pi by 4 is equal to 1 by 2. Sin x is equal to 0, it's a trigonometric equation, you have to solve, but you have to solve for the values of x that belongs to S. Now sin x is equal to 0 will give rise to x is equal to 0, pi, 2 pi, but x 0 and 2 pi are not included in S, therefore we take only x is equal to pi. Agreed. Sine of x plus pi by 4 is equal to 1 by 2 is a trigonometric equation, and sine of theta is equal to 1 by 2 for theta is equal to pi by 6. Then the general solution is x plus pi by 4 is equal to n pi plus minus 1 to the power of n into theta, that is pi by 6. N belongs to z, the set of integers. Now this will imply x is equal to pi, x plus pi by 4 is equal to, for n is equal to 1, pi minus pi by 6. For n is equal to 2 pi plus pi by 6. Now we may ask a question, sir, n belongs to z. There are several values of n that belong to z. And we have taken only n is equal to 1 and 2. Why? If you take n is equal to 0, it is negative. X value is negative and the negative values are not there in S. And if you take and the other one, n is equal to minus 1, n is equal to minus 2 and so on and so forth, for all negative values will get. Therefore, we need not consider 0, minus 1, minus 2, so on and so forth. For n greater than or equal to 3, n greater than or equal to 3, you will get positive values, no doubt about that, but they will be outside the S. Outside the S. Therefore, these are the only two values what we have to consider. Now solve for x. So this is x is equal to pi. X is equal to pi minus pi by 6 is 5 pi by 6 minus pi by 4. And 2 pi plus pi by 6 is 13 pi by 6 minus pi by 4. And simplify. X is equal to pi. X is equal to 7 pi by 12 and 23 pi by 12. These are the x coordinates of the points of intersection of the solution, and the given curve y is equal to root 2 sine x. And the answer, now you have to consider the sum of the abscisses. That we do it in the next slide. And we get these things. And what is the question? The question is the sum of the abscissa of all the points of intersection of the solution y is equal to yx with this curve. We have already done it, and we got the points of intersection, we got the abscissas, and if you sum it up, that is given to be k pi by 12. First, the sum of the abscissas is pi plus 7 pi by 12 plus 23 pi by 12, and simplify, we will get 42 pi by 12, and it is given to be k pi by 12 in the question. Now solving for k, you will get k is equal to 42. So that is k is equal to 42 is the answer for this question, and that is the detailed discussion of the solution of the problem from the section Differential Equations, which is based on the concept of a solution curve. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.